So the last thing I have to show you is, does a reaction occur? And so the reaction would be given to you, like so. And what we have to do is we have to look at that table and figure out whether or not this reaction is something that would happen. The way we look at that is, you see that there's nitrates involved here, and that's just because they're spectator ions. That's just because we don't typically just write ions on its own. So if you see something like this, what you really see is Al plus 3. And what you really see here is Pb plus 2. So what I'm looking at is that I have, if I split it in half, I have Al plus 3 is going to Al, and I have Pb is going to Pb plus 2. And I got that because I know nitrate is minus 1, and there's 2 of them, and that Al is plus 3 because there's 3 of them, and that's minus 1. I can go ahead now because I know enough about redox to take care of where my electrons go. So this must have had 3 electrons being added, and this must have had 2 electrons being added. And so now I need to take a look at my table of standard reduction potentials. So here's my table. And so if I look here, here's my aluminum one, okay? And notice that it's written in the same way. It's written as a reduction reaction, just like I have. And so I know that that voltage is negative 1.66. Move down here, and I can find my lead reaction here. And notice that it's written as a reduction one, but I have it written as oxidation. And it's also negative 0.13 in this direction. So if we go back to our PowerPoint here, what I know is that this here was written in this same order. So this was negative 1.66 volts. This was negative 0.13 volt, but this is the reverse of the reaction. So because I reversed the reaction, I reversed the sign, so I want to write this as plus 0.13 volts. When I add this all together, okay, so notice what I'm going to do here to make my reaction balanced. When I add this all together, my electrons have to be equal. I'm going to multiply this by 2. I'm going to multiply this by 2 and get 6. I'm going to multiply this by 2. I'm going to multiply this by 3. I'm going to multiply this by 3. And multiply this by 3. I am not going to multiply those numbers. I am not going to change those numbers. The only thing I did was I changed this sign because this is now written as an oxidation reaction. My electrons cross out. I add this together. My overall reaction is 2Al plus 3 plus 3Pb yields 2Al plus 3Pb plus 2. And this ends up being negative 1.53 volts. The reaction will not occur. Okay? If my overall reaction is negative, it will not occur. It will occur in the reverse reaction. So if I took aluminum metal and I put it in lead ions, that reaction would occur, and I would have a flow of voltage. Okay? Let's take a look at another one here. So I have AgNO3, which is really just Ag+. I have ZnNO3 too, which is really just Zn plus 2. And again, I'm going to go ahead and look those up on my chart. I can split them in half here so I know what I'm looking for. I have Ag+, plus an electron goes to Ag. Okay, and that's my reduction reaction. And then one that I'm going to reverse is that I have Zn goes to Zn plus 2 electrons. It's only ever two things. It's not like there's multiple things that we need to compare. This will be my reaction that I will copy in the same order because this is my reduction reaction. This is the one that I'm going to reverse the sign of because I've reversed the reaction. So let's check that out. Okay, so let's take a look here. Here's my reaction with silver. Okay. So we notice that one's going to stay in the proper direction, so that's 0.8, and that's okay. Oh, I can't believe that just deleted that there. Let's undo that. And then up here, here's my zinc reaction. Okay, and so up at the top here, my zinc reaction, is negative 0.76. It's at the top here. My pen isn't indicating it. There we go. It's up here. Okay, so this is the one that I'm going to reverse. So it's negative 0.76. I'm going to make it positive 0.76. So we had said this one here was 0.80 volts, positive. This one had been negative 0.76, but since I reversed it, it's positive 0.76 volts. I can go ahead and balance this. I need to multiply this by 2, and this by 2, and this by 2. This is going to cancel out. I'm not going to double that 0.80 volts. Keep it simple. Ag plus Zn 2Ag plus Zn plus 2. Anything that's an ion is always aqueous. Anything that's not is always solid. And when I add this together, I get plus 0.56 volts. The reaction will occur because it is a positive voltage.